Hi everyone, I hope everybody is safe at home. Being indoors, we'll also start learning our daily lessons through these video classes. So the first lesson we're going to deal in physics is about semiconductor electronics. Before getting inside the lesson, we'll just see about what and all we're going to learn in this lesson. So first we'll see about the history of semiconductors. That is where, how, when, who invented it, what is the reason we have moved to the semiconducting materials. And then the difference between conductors, insulators and semiconductors based on the energy band diagram. Then we'll go to the types of semiconductors. What is a PN junction? First, we'll see the uses of semiconducting devices, where and all it's been used. So you can see them, it's been used in laptops, mobile phones, refrigerators, computers, cameras, televisions. So earlier we used the box type television. We used to have huge televisions in our home. Now we have all that flat screen, LED, LCD monitors, even mobile phones. We used to have that button type. And now we use this touch screen and all. How it is being possible? So it's all been possible due to these semiconducting materials. So it is necessary for us to know about these semiconducting devices. So let's see more about the semiconductors. So let's see more about semiconductors. So we'll see what are semiconductors. Semiconductors are the materials which have conductivity between conductors and insulators. Already in our lower classes, we have learnt about conductors and insulators. So it's nothing but conductors are the materials which allow electricity to flow through them, and insulators are the materials which do not allow electricity to flow through them. But the semiconductors, they have some two important properties which makes them more important than conductors. The first one is it allows the conductivity to be controlled. It's that you can control the flow of electrons, you can control the number of electrons which are flowing in an electronic device. Or you can also say that the flow of current can be controlled in an electronic device. This is the first one. Then the second property is the unidirectional flow of current. That is, in a semiconducting device, the current can be flowed in only one direction. So the current will be flowing in only one direction. So these two properties, that is, your conductivity can be controlled and the unidirectional flow of current plays a very important role for the semiconducting materials. Now we'll see about the history of semiconductors. So before semiconductors arrived, what did they use for controlling the electronic devices? So they used vacuum tubes or valves. Later on, they moved to transistors, which is a semiconductor device. So you can see the picture of a vacuum tube. So what is present inside the vacuum tube, we'll just see. So the semiconductors was first invented by Michael Faraday. And why did Michael Faraday move to semiconductor? How, and what is present inside the vacuum tubes we'll see, and how does it work? So if you see here, you have a video. So there's a glass tube, a glass container, and it contains of a cathode, an anode, and a grid. So vacuum will be developed, will be created inside a glass container. So a cathode is being supported with a heating element, that is tungsten. So once the element has been heated up, the electrons which are present in the cathode will move towards the anode. So you can see how the electrons are moving. So as the electrons move or electrons flow, you will have the flow of current and the bulb starts glowing. But it had a little bit of a disadvantage. So we'll see what is the disadvantage of this. What are the disadvantages of the vacuum tubes also. So if you see the vacuum tubes, the disadvantages of it were they were bulky. We need to create vacuum inside the glass container, and it operated at high temperature, high power, and it needed high voltage. and it was less reliable also, and its lifetime was also less. But whereas when you see semiconductors, it was more advantageous than the vacuum tubes. So it was smaller in size. So that's the reason we can say everything has been small in size. Like we had bigger televisions, now we have the flat screen monitors. And then no vacuum is required, and it consumes less power, and it operates at less voltage, and it has a long life, and again it has high reliability, and it is highly reliable. So that's the reason we have been moved from vacuum tubes to. So here we have few semiconducting devices. You can see like LED, light emitting diode, photodiode, we have Zener diode, which acts as a regulator, voltage regulator, which is used for regulating voltages. And we have different types of LEDs, also the colored ones. So all these colored ones, it depends upon the type of semiconducting material what we are using. And we also use lot of chips in the mobile phones or in the CPUs. So ICs also, integrated chips, is being used. So all these include the semiconducting materials. So these are certain examples, and we will be learning about few semiconducting devices like Zener diode, and then we'll learn about LEDs, how do they work, how a photodiode works, what is the use of it, all those things we'll be learning. The next one is an important thing, that is how the metals have been classified. So here I have just listed out the properties like conductivity, resistivity based upon the classification of metals like conductors, semiconductors and insulators. So if we see for conductors, the electrical conductivity is very good. That is, it has more number of free electrons, but for insulators, it does not have any free electrons. So this is the reason that conductors conduct electricity and insulators, they do not allow electricity to flow through. Then if you see about the resistivity, so resistivity here in conductors, as the temperature increases, the resistivity increases, and in case of insulators it remains constant. But if you see in case of semiconductors, the conductivity is lying between conductors and insulators, and resistivity is inversely proportional to temperature. So this is the basic classification of metals, but here we're going to learn in detail based upon the energy band. So what is this energy band theory? There are three important bands in the energy band theory. So what are those three? We'll see. First one is valence band, second one is conduction band, and the third one is the forbidden band. So we'll see individually what are these three bands are saying about. So first we will see about valence band. So valence band is the band which is very close to the nucleus. The electrons which are present in the valence band are called valence electrons. So as the electrons are very close to the nucleus, they experience a very strong nuclear force and they cannot move at all. So, and even when an external field is applied, they will not be able to move, and hence they are called as bounded electrons. The next we have conduction band. So this is the band of energy band which is very far away from the nucleus, and in this band the band orbitals have high energy and they are generally empty, and the electrons which are present in this conduction band, they are usually very weak. That is, weak in the sense they do not have any strong nuclear force, so weak nuclear force, and they move very freely. So that's the reason we say that conductors have free electrons. So this is the only reason why conductors have free electrons. That is, the electrons move freely in case of the conduction band. Then we have the energy band gap. So as the name says itself, you can say it's just a gap, and in this band gap there are no electrons present, and it's a gap between the conduction band and the valence band. The energy band gap here will be differing according to the materials. It may be small also, it may be large also, or it may be zero also. I have the energy band diagram for all the three, that is for conductors, and we have for insulators, and we have for semiconductors. So if you see, the lower band is the valence band, and at the top we have the conduction band, and in between we have the forbidden gap, that is the energy band gap. So in case of insulators, we have a large energy band gap. And due to this large energy band gap, what happens is the electrons cannot move from the valence band to the conduction band. This is what happens. And if you see in case of conductors, the valence band and the conduction band, they overlap with each other. So the energy gap is zero there. So the electrons can easily move from the valence band to the conduction band. So the overlapping of band indicates a large number of electrons will be available in conduction, and a small amount of voltage will be sufficient for a large amount of current. And now in case of this semiconductor, you can see the forbidden energy gap is separated and it's very small, and the range of this energy gap is almost greater than 3 electron volt. So here what happens here is the energy gap is very small. So a small amount of energy is required for the free electrons, for the electrons which are present in the valence electrons to move to the conduction band here. And a very most important thing is that at 0 Kelvin, all semiconductors act as insulators, and only when the temperature is being increased, the electrons start moving and we have conduction. The types of semiconductors are, we have intrinsic and then extrinsic semiconductors. Intrinsic are the pure ones and extrinsic are the impure semiconductors. The major intrinsic semiconducting materials are silicon and then germanium. So in silicon and germanium, if you just see the video there, the outermost shell is not filled, it's partially filled. So it has 4 valence electrons in each of them. So now let's see in detail about the intrinsic semiconductors. So if you just see here, we have 2 silicon atoms. So when they combine with each other, they form a covalent bond. So let's see in detail about it, what happens to the current which is flowing in an intrinsic semiconductor. In intrinsic semiconductors, it is the pure form of semiconductors, and we'll just take an example of this silicon atom, what happens in it, how the current is being flowing in an intrinsic semiconductors, how it forms a covalent bond in a solid. So first thing, we'll just consider a silicon. It has 4 valence electrons. So when you consider a solid, it's not that it's going to have one silicon atom. It will have millions of silicon atoms. So all silicon atoms, they are having 4 valence electrons. So each of the electrons, they will form a bond with the neighboring electrons. So you can see there are many atoms, and all the valence electrons, they form a bond with the neighboring valence electrons. And this sharing of electrons is called as the covalent bond. So now what happens here is the bond is very strong and it will not break. So at lower temperature, they act as insulators. When temperature increases, the electrons start moving. So free electrons are being produced. So in the place of the free electrons, you can see there a hole has been created. The place has been empty there. So the vacancy which has been created by the electron is called as a hole. And gradually what happens is that hole is again being replaced by the electrons here, by the neighboring electrons. So like this the process goes on, and once the electrons start moving, so flow of electrons are there, obviously there is a flow of current here. So two things we need to we need to concentrate. First one is you will have a vacancy will be created, that is holes. Recombination of electrons and holes and generation of electrons and holes will be present. And the number of electrons will be equal to the number of holes. That is, if the electrons move, a hole will be generated, and again that another electron will come and occupy its place. And the total current which is being produced in an intrinsic semiconductor will be the current due to the electron and the current which is due to the holes. Now we're going to see about extrinsic semiconductors, how they are different from intrinsic semiconductors. The pure form of semiconductors are intrinsic, and the impure form is called as extrinsic. That is, we are adding impurities to improve the conductivity of the semiconducting devices. We have two types in that. One is P-type and then N-type. In P-type, we will be adding trivalent impurities. So you can see there in trivalent impurities, in the valence band they have 3 electrons. And in N-type, we will be adding pentavalent impurities. That is, in the outermost shell, they will have 5 valence electrons. So you can see there boron is having 3 valence electrons and phosphorus is also having 5 valence electrons. So by adding the impurities, we can improve the conductivity of the semiconducting materials. That is, it is nothing but we can improve the flow of current in the semiconductors.